There's something about a giant ball pit that strikes fear in the hearts of children, and maybe some adults, that you'll jump in, sink to the bottom, and never be seen or heard from again. The fear of ball pits may be unfounded here on Earth, but out in space, it turns out it's kind of justified. Because we could have lost a spacecraft when it tried to touch an asteroid. Bennu, or 101955 Bennu if you're fancy, is a rubble pile asteroid usually found somewhere between the orbits of Earth and Mars. The term rubble pile is used for asteroids like Bennu, which are built up from individual chunks of rocks, but there isn't enough mass or gravitational attraction to fuse them into one solid rocky body. Scientists hypothesize that between 700 million and 2 billion years ago, a larger asteroid was smashed into bits after colliding with another space rock, and some of those bits later reformed as Bennu. But the raw materials, the basic minerals inside of Bennu, are way older, forming just 10 million years into our solar system's life. It's a cosmic time capsule astronomers can study to learn about our origins, which started over 4.5 billion years ago. So, back in 2016, humanity sent the spacecraft OSIRIS-REx, not just to visit Bennu, but to bring samples back to Earth for analysis. OSIRIS-REx arrived in 2018, collecting data in orbit for a couple years. Then, on October 20th, 2020, it descended upon a site dubbed Nightingale. The probe was supposed to touch the solid surface of Bennu for several seconds and release a burst of nitrogen gas to kick up a small collection of pebbles and dust into its sample collector. The mission was called a touch and go, or TAG, but the real touch was more like a sink almost 50 centimeters beneath the surface. And the go part was a little more dramatic too, because the probe ended up leaving not a delicate footprint, but a crater 8 to 9 meters wide. While the sample collection was a success, the weird results demanded a follow-up. The mission team ordered an extra flyby to snap photos of the tag site to collect more data. And the data revealed that the rocks on and just under Bennu's surface have near zero cohesion, the force that helps things like water or flour grains stick together. That means Bennu's surface rocks are held together solely by their very, very weak mutual gravitational pull. That explains why OSIRIS-REx's departure made such a large crater. The rocks were way more susceptible to being flung away by the oomph of OSIRIS-REx's thrusters. Before the tag, scientists knew Bennu's surface wouldn't have a whole lot of cohesion, at least compared to other rocky bodies in the solar system. But based on the asteroid's overall shape, they expected there to be some. And the fine particles that scientists expected to be in Bennu's near subsurface weren't there. They had either sunk deeper into Bennu's interior or been flung off into space. So instead of rocks and dust working together to form a solid surface, the individual rocks just jostled around, sliding over one another when they got disturbed, like molecules of a liquid, or like balls in a ball pit.